So, in addition to yesterday's, we had talked about multiplying things by 10, right? So, when we multiply things by 10, all we did was we literally did this. 7.1 times 10. So we would think of 7.1, we'd look at the decimal where our value was, and then we would move it over one space. So all we're looking for is finding out what our final answer is, and we end up with, in this case, 71. So another way to look at this would be take a number with a 1 and a bunch of zeros after it, and just count the number of zeros. So let's check that out. So this is our second example. Let's call it example 2. That was example 1. And so let's say I have 5.4 times 10. So we can look at this as count the number of zeros after the 1 when we're dealing with something with a 10. So there's only one space. So that means we're going to move the decimal over one space. So we end up with, instead of 54, we have with 51, we have 54 as our final answer. Okay? So this rule can be generalized when we talk about dealing with stuff that are multiples of 10. Another multiple of 10 that we've seen before is multiplying by, say, 100, or 1,000, or 10,000. Now, if I do that and I use the rule that we just looked at before, i.e. we count the number of zeros and then move the decimal the same number. Okay, so for example, let's say I have 5.412, and I'm going to multiply that by 100. So how many zeros do I have here? I have 2. So that means we're going to move the decimal twice. Ready? Here's my decimal. 5.412. 1, 2 spots. So our decimal has to be between the 1 and the 2. So our final answer is 514.2. Now, I'm going to ask you to try this next one here. Let's say I had 3.14159, and I multiplied it by 10,000. All right? Pause the video, try to find the answer, and then we'll write the answer together. Okay, so here's what we do. We count the number of zeros. 1, 2, 3, 4. There's 4 of them, which means we have to move this decimal that we have here to the right 1, 2, 3, 4 spots. So our decimal needs to be between the 5 and the 9, which means our final answer is equal to 31415.9. All right. So now let's go on and take a look at the problems that I provided for you to work on today. Now, you're going to work on these on your own, but I want you, when you do these problems, you're going to show me the full solution that you see on this next page. Here's a problem that I'd like you to try. All right, so for these problems that you're going to see for our homework for today, you're going to see a problem that looks like this. So if 2 times 3 is 6, then 200 times 3 is some number. Now, 200 times 3 doesn't look anything like 2 times 3, does it? Let's go and let's look at this. So 200 really means 2 times 100, doesn't it? So if you think about it, it means 2 times 3, then times 100. Ooh. So that means what we could do is we could look at the number of decimals, or sorry, zeros in our 100 to find out how much we have to change our original number, which was 6, into our new number. So here's what we're going to do. We're going to write our number here, and then we're going to imagine there is an imaginary decimal here, and we move our decimal to the right 2 spots. Now that is where our decimal should be. So I'm going to put a nice big decimal here. And then I'm going to put 2 zeros after my 6. So it's 600.0. So my final answer, when I simplify it, is just 600. Now, on the work that you're going to do for today, I want you to do problems just like this. So, for example, if I had, let's say I had this question here. This is example 7 times 8 is equal to 56, right? Then 7,000 times 8 is equal to some number, okay? So what you have to do is you're going to have to do what we did before. Pause the video and then try this out. See if you get the same answer I do. So first of all, 7,000 is really 7 times 1,000. When you hear 7,000, it means 7 times 1,000. So now we've got that. And if we're really looking at it, the two smallest numbers are 7 and 8. So 7 times 8 is the same as 56. So I'm going to use that 56 from the beginning, just like I did before. And then I'm going to say where my decimal is. So my decimal is to the right of the whole number. So I'm going to imagine it starts there. And for our 1,000, there are 1, 2, 3 zeros. So that means we need to move the decimal place 1, 2, 3 spots. And now that I've got my 3 spots filled out, that is where my big new decimal is going to be. So now I can write the rest of my answer. So I got 56 with 3 zeros after it and a 0. Now the 0.0 really means nothing, but if there was a decimal after, you just put the decimal. So this is really 56,000 for our answer. Now, the types of questions that you're going to have are based on these questions, and I would like you to do some practice questions online, but then I'd like you to do the problem by hand, showing the work that we have done here and here. I'd like you to do problems like those two on the sheets, but you're going to practice the questions first. You're going to do maybe 10 questions, 12 questions. Then you're going to do the problem worksheet that I provide for you. Those sheets will be posted online in lesson 2.1. This is the next supplement to the work that we're going to be doing. So now, in summary, what we're is when we multiply by tens, by something that's like a 10, 1,000, 100, 10,000s, we need to, 1, count the number of zeros, and then move the decimal right. That same number. So here's our final example. Example is 0.3126 times 100. So we're going to take a look at our problem. We find that this is the number of zeros here is 2 zeros. So here's what we do. We take our 2 zeros and then we go over here and we move our decimal 1, 2 spots. So there is where our decimal needs to be, between the 3 and the 1 and the 2, 6. So here's what you do for your final answer. So your final answer is 31.26, and we're done. We'll go to 10 questions on Common Core sheets. Download the notes, the final question sheet that I've given you, and do that by hand and show me your solutions, please.